All right, let's talk about something that you use every single second you're online, but probably never think about: the IP address. We're going to break it down because it's basically the invisible postal service that makes our entire digital world go round. Okay, let's dive in.
So think about it for a second. How does it actually work? When you type a search into Google, how does the answer find its way back to your specific phone or laptop and not, the one sitting right next to you? That's the huge problem we're going to unpack. And the answer, of course, is the IP address. The IP just stands for Internet Protocol, and its job is actually pretty simple, but it's absolutely crucial. It's a unique number for your device on a network, just like your home address is the one and only address for your house in your town. And that analogy? That's the one you're going to want to hang on to. Now, there are a couple of different versions out there, but for this explainer, we're going to focus on the classic, the original powerhouse, IPv4. It's the 32-bit system that pretty much the entire internet was built on. You've seen these numbers everywhere, something like 192.168.1.1. Okay, so if every single device in the world needs a unique address, how do you organize literally billions of them without it just becoming total chaos? Well, the first big idea was to create what you can think of as digital neighborhoods. These are officially known as IP classes. Yeah, the folks who first designed the internet, they knew it was going to get big. So they pre-sorted the entire pool of available addresses into different sized blocks. This was a really smart way to bring some order to the madness and organize the internet into networks of all different sizes. And here's kind of how it was broken down. You had Class A, that was for the absolute giants, giving them millions of addresses. Then you had Class B, for medium-sized networks, think big universities or corporations. And finally, Class C, which is by far the most common, was for small networks, like the one you probably have in your house right now. Each one was a different slice of digital real estate. And then you had a couple of specialty classes. Class D is for something called multicasting. You can think of it like a radio broadcast, where one signal goes out to a whole group of specific listeners at once. And Class E? Well, that was just set aside for research and experiments, basically the internet's R&D department. Okay, so we've got the neighborhood, the IP class. But once a message gets to the right street, how does it know which specific house to go to? How do you separate the street name part of the address from the house number part? Well, that's where our next piece of the puzzle comes in, the subnet mask. So the subnet mask always works side by side with the IP address. Its one and only job is to draw a line in the sand. It tells any router or computer which part of the IP address is the network, that's the street, and which part is the host, that's the specific house number on that street. So here you see a classic IP address on the left, and right next to it, it's subnet mask. Now, I know it kind of just looks like another IP address, but what it does is totally different. And those two 55s, they're the real key to understanding its job. Right, so think of the subnet mask like a stencil. You lay it over the IP address. Wherever you see a 255, that part is masked out. It's locked in as the network or the street name. In this case, that's 192.168.1. And wherever you see a 0, that's the open part of the stencil. That tells the router, hey, this is where you look for the individual house numbers, like the .10 for our specific device. Okay, so this brings us to a really practical question. Are all IP addresses the same? Can any IP address be seen from anywhere in the world? And the answer is a big no. We've got to make a distinction between the address the whole world sees and the ones we use inside our own homes. Your public IP address is like your main official mailing address. It has to be totally unique across the entire globe so the internet can find your house. But your private IP address, that's more like an internal phone extension at an office. Extension 101 only has to be unique inside that building. Same idea here. It only needs to be unique inside your local home network. And to make sure this whole system works without any confusion, they set aside a few special range of addresses just for private use. And chances are you've probably seen these before if you've ever poked around in your router settings. Any address starting with 10 or 172.16 or the super common 192.168, those are all reserved for private networks. So how do all your phones, laptops, and smart TVs, all with their own private IPs, get online? Well, your router acts like this brilliant, overworked translator. Your laptop uses its private IP to tell the router, hey, get me this website. The router then takes that request, sends it out to the internet using its one single public IP address, gets the website back, and then translates it, making sure that data goes to your laptop and not your roommate's gaming console. So why does all this matter? I mean, why go through all this trouble with classes and masks and public versus private addresses? Well, it's because this whole layered system, this clever setup, is what makes our modern digital life even possible. Right now, there are over 30 billion devices connected to the internet. 30 billion. Without an organized addressing system, it would just be an impossible, chaotic traffic jam. This structure is what brings order to that unbelievable scale. And that right there is the big takeaway. It's this beautiful combination, a single public address for the outside world, and all these private addresses managed internally, all sorted out by subnet masks. That's what lets you have a dozen different devices in your home, all seamlessly sharing one connection to the entire global internet.
You know, at the end of the day, it all comes back to that simple idea we started with. It truly is a sophisticated, completely invisible postal service. It sorts, directs, and delivers trillions of digital packages every single day, making sure every last message finds its way home. But that leaves us with one final and really important question. This original class-based system was pretty rigid, and we have already completely run out of new IPv4 addresses. So, with a future that includes smart everything, smart cars, smart cities, trillions more devices coming online, is this system really built to last? Or is there a new, more flexible system that's already taking over? Well, that's a story for another time.